Hi, today we are going to talk about um, geometric sequences. Okay, so first we need to um, define what is a geometric sequence. So we know that a arithmetic sequence is a sequence of a common difference. So how about geometric sequence? Geometric sequence is a sequence with a common ratio. Alright. So normally we denote that common ratio as R. Okay. Okay, so that's basically the definition. Okay, let me give you some illustrations. What are the geometric sequences? Okay, for example, if my first term so if my first term is 2 and my second term 6, okay, so you know that from 2 to 6 you need to multiply by 3, right? So what about the next term? It should be 18, right? And how about the next term? Okay, then because the ratio must be constant, that means you need to multiply by 3 again. So that becomes 54, alright? Okay, so this is a sequence with common ratio 3. Okay, and how about the next one? So I give you another example. Okay, so for this sequence, you see that um, uh, the numbers becomes greater and greater because the common ratio is greater than 1. Okay, how about if the sequence becomes smaller in value when the common ratio is less than 1? Okay, so let's think about if we have a sequence of the common ratio less than 1, how about 2? Okay, let's start with 32, alright? If the 32 is the first term, how about the next term? Okay, because the common ratio is 1/2. Okay, so that means each time we need to multiply by 1/2. Okay, becomes 16, next one 8, yeah, next one 4, next one 2. Okay, so that's another one. Okay, so we see that for geometric sequence, the number can become greater and greater, or it becomes smaller and smaller. Okay, how about if the common ratio is a negative number? For example, let's say the common ratio is -2. So what happens? First, think about the first term. First term can be anything. Let's say if we give you a really simple number, let's start with 1. How about the next term? 1 times -2 becomes -2, right? And then you multiply another -2, and negative multiplied by negative number becomes positive. The next one, positive 4 times -2, it should be -8. Okay, so you see this term is alternating, isn't it? Because the numbers positive, negative, positive, negative. Okay, so these all are geometric sequences. Okay, because they all have a common ratio. All right. So do we have any general rule for geometric sequencing? First, the general rule is we've learned that it's a recursive rule. Okay, it's recursive. It's a recursive rule or recursive formula. For recursive rule, you always have Tn equals Tn minus 1 times, and we multiply by the common ratio. Okay, so you should have got used to these kinds of notation, right? That means for each term in the geometric sequence, it would be equal to its previous term times the common ratio. Alright, and the common ratio should be found by Okay, how can we find the common ratio? Common ratio can always be found by the term divided by its previous term. Okay, so from this recursive rule, we have one implication. It's like this, right? All right. Okay. So for example, let's use this one, our first one, as one of the examples. So for this geometric sequence, how could we write the recursive rule? Okay, we know that for this one should be Tn equals Tn minus 1 times 3. But for recursive rule, you need to have a starting term, right? We need to give the rule a the first term, right? So you need to write like T1 equals 2, okay? So when you are going to find T2, you just use T1 times 3, you got second term, and so on, alright? So that's the recursive rule. Okay, so how about another rule which would be much more common in our study? Okay, this is what we call explicit rule. Okay, so explicit rule is going to build up a relation for the term, okay, for each term with the first term, okay. So instead of consider the relation between two consecutive terms, you need to relate each term to the first term, okay. Let's see how that happens. All right. Okay, I use this as an illustration. Okay, again. Okay, so let's see. Mouse went to where it room. Okay, so let's see what happens here. Okay, we know that for this one, if you go from the first term to the second term, you multiply by 3, right? And if you go from the first term to the third term, you multiply by what? Multiply by 3 and times another 3, right? Because you multiply by 3 to get 6, and 6 multiplied by 3 to get 18. So from 2 to 18, you are going to multiply 3 twice. Okay, so that means it should be multiplied by 3 squared. Alright, so how about the fourth term? Okay, so the fourth term, we are going to multiply that one by 3 to the power 3. Okay, and so on. Okay, so how about we are going to Tn, the nth term. How many 3's are we going to multiply? Okay, so let's see the pattern. Okay, so this is first term, right? So this is the second term, this is third term, this is fourth term. Okay, so for second term, you multiply the first term multiplied by 3. Okay, for the third term, the first term is multiplied by square of 3. That's the 3 to the power 2. For the fourth term, it's multiplied by the cube of 3. That means the power 3 of 3. Okay, so for the second term, you multiply by 3 to the power 1. For the third term, you multiply by 3 to the power 2. For the fourth term, you multiply by 3 to the power 3. Okay, so have you seen the pattern? Okay, so let me ask you, if we are going to do Tn, okay, if we are going to find Tn, okay, and how many 3 I'm going to multiply to multiply to that first term to give me the nth term. Okay, so it must be multiplied by 3 to the power something, right? How many 3 are going to multiply? Okay, so if that's 4, the number of 3 are going to multiply 3. If that's third term, the number of 3 are going to multiply 2. So by using that pattern, you should see that for nth term, we should multiply n minus 1, right? 3. Okay, so you see the line up, right? Okay, so that's the explicit rule. So explicit rule means Tn equals, okay, T1, okay, we are going to start from T1 times the common ratio. 3 is the common ratio to the power n minus 1. Okay, remember, for the nth term, you start from first term, multiply by the common ratio to the power of n minus 1. Alright? Okay? You see that? Alright? Okay. So that's basically our explicit rule. We are going back to explicit rule later. Okay. But now let's have some to do some very simple questions. These are all simple, familiar examples in this video. All right. Okay. Let's see for our first one. Okay. You need to identify geometric sequences. Okay. So first one, which of the following could be a geometric sequence? Well, geometric sequences. Okay, remember the definition of a geometric sequence is a sequence with a common ratio R. How could we find that common ratio? You always use the term divided by its previous term. Okay, so let's see. Okay, in this case, that's T1, isn't it? Okay, so that's T1, that's T2, that's T3, that's T4, right? So let's see, if it's a geometric sequence, we should see a common ratio. Let's see if I divide T2 by T1. Okay, so we all know that it should be 3 to the 3 square, right? It should be 9. Okay, is that enough? No, because that just means the ratio between the second term and first term 9. You still need to check how about the third term and the second term. Okay, so the third term is 3 to the power 5, 3 to the power 3. Okay, so it becomes 3 to the power square again, because 5 minus 3 equals 2, right? That's the index rule, right? Again, you have 9. Okay, so you see that's the ratio between the second term, first term, and also the third term and second term are equal. So that means this sequence is a geometric sequence. All right, so the answer for this one, yes. Okay, so how about the second one? Okay, second one, it looks like a geometric sequence. The pattern is always you have 1 more digit with 9, but is it really the geometric sequence? Okay, we need to check. All right, so let's check. I use another color. T2 over T1. Okay, sorry. Allow me to amplify this a little bit bigger. So 99 over 9 should be 11, right? And T3 over T2 is 999 divided by 99. Is it also 11? Need to check. Okay, if you use your calculator, okay, it becomes 10.09. And it's a recursive in decimal, so we might write things like this. Okay, so but definitely they are different, as you can see. Okay, they are different. 11 is not equal to this one, so that means they don't have a common difference. Okay, so the answer is no, because the ratios are different, unlike the first one. Okay, how about the last one, the third? Okay, is a positive, negative, positive, negative. Is it possible that such a alternating sequence be a geometric sequence? Actually, we've got one bit like this, like this example, 1 minus 2, 4 minus 8. They are oscillating, right? From positive, negative, and back to positive again. Right, so let's see if this is really a geometric sequence. Okay, so again, we need to check T2 over T1 minus 100 over 10 minus 10. Okay, and T3 over T2 is 1000 divided by 1 minus 10. Okay, are they the same? Yes, they are the same. Right, so that means this is a geometric sequence. Alright, so that's how could we identify a geometric sequence. Okay, so for example 2, you don't need to identify whether it's a geometric sequence because it's given as geometric sequence, so you don't need to prove the status of being geometric sequence, right? But you need to write down the common ratio and the general term. So there are 2 tasks for each one. Okay, how could we find the common ratio? Remember, common ratio, you always need to use the a term divided by its previous term, right? Okay, so let's see. For this one, R will just equal T2 over T1. Okay, that's 3. Okay, so that's a common ratio. But do we need to do T3 over T2 again, like what we have done before? No, in this case. Why? Because the last case, you need to identify whether it's a geometric sequence. So that's why you can't just find out T2 over T1. You need to check whether T3 over T2 equals T2 over T1, right? In some cases, actually they are not equal, like in the case 2. But for this example, as I've said, it's given that they are the geometric sequence already. So you don't need to do that T3 over T2 because it should be 3 anyway. Okay, so you save that step. So common ratio is 3. How could we find the general term? Remember what the general term looks like. Okay, the general term looks like this one. Is Tn equals T1 times R to the power n minus 1, right? Okay, so if we use that general rule, you are going to find Tn equals T1 R n minus 1. Okay, but that T1's 2 and that's R is 3, so that's 3 to the power n minus 1. Okay, so be a bit careful here. Alright, we've already got the answer, but some students, they might think, can we multiply this 2 and 3 become 6? Can we do that? Think about this. Can we multiply 2 with 3? It's really tempting, right, to do so, but it's a temptation, but it's wrong. Okay, why? Because we know that's the power as a priority, has what we call the conventional order, right? So you need to do the power first and do the multiplication. So that's 3 is prioritized by that's power. Okay, so it can't be used to multiply 2. Alright? Okay, so you can't simplify that further. Make sure you understand this. Alright? Okay. For the second one, okay, again, you see there's negative sign here. Okay, so if you got positive, negative, positive, that means it's an alternating geometric sequence. Alright? Okay, but again, you apply the same process again. Okay, so what number do you get? Okay, it should be minus 9 over minus 3. Okay, so I'm going to give you some time to write your answer, right? Okay, I'm going to to give you 1 minute to do so, right? Okay. Okay, I suppose that's 1 minute. If you haven't got enough time, you might pause the video to spend more time on it. Okay, you can always pause the video to try to understand the thing if you think it's too quick. Yeah, that's the advantage of having video lessons rather than live lessons. Right? Okay, so Tn equals T1 R n minus 1 to the power. Alright, that's all the same. The first three is 3. The common ratio is minus 3 and minus 1. Is that your answer? Is that your answer? If that's your answer, be careful. Possibly you've got it wrong. Why? Because you need to put a bracket here. May I use another color? You need a bracket here. That's very important, right? Okay, because we know that the minus 3 to the power n minus 1 is always a negative number. But if you got the bracket on that's negative 3, then this number could be positive or negative, right? Okay, right. So if you still don't understand, let me give you some illustration. For example, if you write minus 3 square, it should be minus 9 because you have to do that 3 square first. So it becomes minus 9, right? But if you give it a bracket and then square, it becomes minus 3 times minus 3 because the minus 3 is a whole unit. So if you square it, that means you got 2 minus 3 multiply each other, becomes 9. So you see the difference, right? So that's why that bracket is very important. Alright, so for the last questions, it could be a bit tricky because I give you R, but this R is not the common ratio. Normally we use R to refer to the common ratio, but in C it's not quite the case. Yeah, because the R takes the position of first term, and also if you look at the so-called common ratio, it should not be R, but R power 3, right? Okay, so we don't use R equals T2 over T1 because that would be confusing. Okay, so you write common ratio. Okay, let's say the common ratio. Okay, we use the description to avoid any confusion. So common ratio equals T2 over T1, and T2 is R4, T1 is R. So that's 4 minus 1, isn't it? So that's R3, right? Okay, so that basically means the common ratio is not R, it's R to the power 3. Okay, so for Tn equals T1 times, okay, remember now, it's no longer the common ratio is not R, it's R to the power 3. Okay, so we better write common ratio. We use verbal expression to the power n minus 1. Okay, so that means T1 is R, common ratio R to the power 3, bracket n minus 1. Okay, so we need to do a bit of simplification because you know that 3 can use to multiply. That's n minus 1 in the index. So R times 3n minus 3. Okay, distributive law. Okay, so that's the r to the power 1. So if you are not quite used to that index law, you might need to spend a bit more time to understand this, right? But that will be the answer, right? Okay. So for C, possibly it won't be a simple familiar question, right? So because it involves a lot of algebra, but the idea is actually not that difficult, all right? So normally, if they give you the sequence and they ask you to find the general term, things like this, they are not that difficult. They are just simple familiar, right? Okay, good. Okay, make sure you have get a good sense of what is geometric sequence. All right. Okay, so we might pause here for some time. Okay, so let's continue. All right. Okay, so example 3 is about given the express rule, you need to find the first term and common ratio, right? Okay, so this time they give you the rule, and then you're going to find the first term, the common ratio. Okay, all right. Okay, so what do you mean by the general term? Okay, so general term here just refer to the explicit rule. Okay, so why explicit rule look like this? Okay, you need to go back to see. If we go back to here, right? Okay, so that's the explicit rule. So all explicit rule can actually be simplified into a form that looks like an exponential function. Okay, for example, if you use this one as an example, then the Tn will actually equals 2 times 3 to power n minus 1, right? So that's the explicit rule. Okay, and sometimes that explicit rule can be changed to other form, right? Okay, so for example, this is one of the form that possibly will use a lot of time, but there will be other form as well. For example, you might change this form like 2 times 3 to power n divided by 3. You might use this form. Okay, so there are all sorts of different ways to express this explicit rule, although all explicit rule can be started from using this general form, right? Okay, so let's go back here. How could we find the first term from this one? What do we mean first term? Okay, remember that first term just means T1 and common ratio is just R, okay? So for A, how could we find that's first term? Okay, so all you need to do is put T1, okay? Okay, sorry, let's say Tn equals 2 to the power n minus 1, right? Okay, just like a function, if its first term becomes T1 and you put 1 into n, you got this one? Can you see that? Just simple substitution. So it becomes 2 to the power 0, that means 1. Okay, so that means the first term is 1. How could we find the common ratio? What do we mean the common ratio? Common ratio always can be found by using the term divided by its previous term, right? So we've already got T1. How about let's find T2? Okay, for T2, you just substitute that's 2 into n. And you got 2 to the power 1, and that's true, right? Okay, so that's T2 equals 2, T1 equals 1. So how about common ratio? Common ratio, we can always use T2 over T1, or any term divided by its previous term. Okay, so T2 over T1, that means 2 over 1 is 2. So that's the common ratio. So the first term is 1, and the common ratio is 2. Okay, we are done here, right? Okay, so B is a bit more difficult because there's a minus sign here. So I'm going to give you some time for you to have some maneuver in that's algebra skills. There's all sorts of negative number, positive number, and index rule. Okay. Okay, so you might spend like 5 minutes on it. Okay, you can pause the video by now and spend 5 minutes on the question, and then and then you can check with my answers, right? Okay, I'm going to give you some time to work on that by yourself first. Okay, good. Okay, so again, if you haven't finished, just pause the video and make sure you get the answer, right? Alright, so to do this one, again, we use the similar process. We need to find T1. Okay, so that's T1. And then we are going to find T2, because you need that's T2 divided by T1 to find the common ratio. And T2 square. Okay, what's the square minus 3? It should be 9, right? Okay, but that's minus 3 times minus 3, okay? It's 4 for 9. Okay, so what's the common ratio? Okay, common ratio would be T2 over T1. So that's 4 over 9 divided by minus 4 over 3. Okay, if you understand how to do division between two fractions, you understand that we can always multiply the denominator, but you need to upside down. Okay, so it's 12 minus 3 times that's 1 minus 1 3. So that's the common ratio. Okay, so you got first term, you got common ratio. Okay, if you got the same answer, that's congratulations. Alright, okay. If you can't, well, make sure you understand which step you are wrong. Okay, good. Right. Okay, so let's move on. Okay, so example 4 is an example. They given the first few terms, and you need to find the common ratio and the general term. Okay, so the common ratio, I know how to find it, but how about the general term? It's very similar to our previous question, so let's just do it. Okay, so for example, this one, okay, the common ratio can always found by T2 over T1. Okay, so T2 is 4, it's minus 2, so it's minus 2. Okay, so how about general term? General term Tn, you always use T1 times R to the power n minus 1. So T1 is minus 2. And R is also minus 2, right? So that's minus 2. Remember the bracket? Okay. Okay, so can we leave the answer like this? Possibly you need to do some simplification this time, alright? Because you got minus 2 times another minus 2 to the power n minus 1. Can we think of this minus 2 as minus 2 to the power 1? Okay, then you could use your index rule. 1 plus n minus 1, right? So that would be minus 2n. Okay, so you see that's a bit of simplification to do sometimes. Okay. Good. Okay, so that's our first question. Okay. Right. So you might pause the video now. I will give you 5 minutes to do the second question. Be very similar, but this time you are going to find the sixth term, and for A you are going to find the general term. Well, it's very similar actually, right? So that's why I just categorize them, these two questions as the same sort of skills, right? So 5 minutes, try it out. Okay, let's track the answer. Alright, A, how could we find the general term of the sequence? Okay, to find the general term sequence, you need to have T1 and also the common ratio. Okay, so obvious, T1 is 3 over 4. How about the common ratio? You can use T2 over T1. So that's 3 over 4. 3 times 4 over 3 becomes 4, right? Okay, so that's common ratio. And then you're going to write the general term Tn equals T1 times R to the power n minus 1. T1 is 3 over 4 times 4 n minus 1. Okay. Is that possible to do some simplification? Yes, if you can see that's 3. That's over 4 is actually, you can think of this one as 4n minus 1 divided by 4, right? Okay, right? You could multiply the 3 with 4 to the power minus 1 first and then divide by 4, okay? But by doing that, that's 4 is actually 4 to the power 1. Then you can use your index law to do the simplification like this, alright? So it becomes 3 times 4 and minus 2. Okay? Okay, so that's our general term, okay? So in the examination, possibly if you leave your answer in this step, you still got most of the mark. I'm not quite sure, but I think you could get your mark. That's just from my judgment, right? I'm not quite sure in the public examination would they accept. I think they will, right? Okay, but it would be much better if you are going to get you are aiming for a high degree, high mark. Then possibly you need to do this final answer. You need to understand how could we get to this step, right? Okay. So for B, you are going to find T6. Okay, so that's sixth term. Okay, that means you just put that 6 into that explicit rule. That's why we need that rule, right? So if you got 6, okay, that's 3 times 4 to the power 4. Okay, so what's the 3 to the power 4 to the power 4? Okay, I try not to use calculator, right? Okay, 7, 6, 8. I better use the calculator. Yeah. Okay. So that's the answer. All right. Okay. So we've done this question. So check your answer. If that's correct, then that's good. Okay. So what we have done in this video, we've learned the definition of geometric sequence. It's a sequence with a common ratio R. Okay. We've learned how to find the common ratio by using the term divided by its previous term. And we have established explicit rule as Tn equals the first term times the common ratio to the power n minus 1. And we've done some simple familiar questions. Our next video will be more about familiar but complex questions or unfamiliar complex situation. Okay? Okay, see you next time. Bye-bye.